Sources of error in weighing. Now, let us identify some of the sources of error in weighing mass of an object. First is the buoyancy. Buoyancy error is the error that develops when an object that being weighed has a significantly different density compared to the mass, thus affecting the data. This error happens when the difference on the buoyant force being exerted by the medium, which is air, on the object and in the mass, meaning that this error occurs when the air exert a buoyant force that help to make a difference on the object and the mass. This error is less than 0.1% for the objects that have a density of 2 grams per cubic meter or greater. So, it is thus seldom necessary to correct the masses of these most solids. However, the same cannot be said for liquids, gases, and as well as solids which have a low density. So, for these objects, the effects of buoyancy become significant, and this error should be corrected. For accomplishing the buoyancy corrections for electronic balances, we use this equation. W1 is equal to W2 plus W2 multiplied by the difference between the quotient of the air over the object and the quotient of the air over the WTS. Whereas the W1 is the corrected mass of the object. W2 is the standard masses, the object is the density of the object, the WTS is the density of the masses, and the air is the density of the air displaced by the masses and object. And the value of the air is 0.0012 grams per cubic meter. Now, in this graph, let's see how buoyancy error affects the mass. We can see in the graph that an object that with zero relative error should have a density of 8 grams per milliliter. But when the error becomes 0.10, the density lowers to 1 grams per milliliter. And we can see that when the error rises more than 0.00, the density of the object also becomes higher. Next is the temperature. Temperature error is resulted on attempts in weighing an object whose temperature is different from that of its surrounding. When a hot sample warms the air, it rises. As a result, convection currents form, making the mass represented unreliable. Errors due to a difference in temperature have two sources. First is convection currents within the balance case exert a buoyant effect on the pan and objects. Buoyant effect is when all liquids and gases in the presence of gravity exert an upward force known as the buoyant force on any object immersed in them. Buoyancy results from the differences in pressure acting on opposite sides of an object immersed in a static fluid. Next is that warm air trapped in a closed container weighs less than the same volume at a lower temperature. It is because according to the gas law, if a gas expands when heated, then a given weight of hot air occupies a larger volume than the same weight of cold air. Hot air is therefore less dense than cold air. Well, these both effects cause the apparent mass of the object to be low. Therefore, heated object must always be cooled to room temperature before being weighed. So in this graph, we will see the effect of temperature in weight data. In this table, we have absolute error as a function of time after an object was removed from a 110 degrees Celsius drying oven. The first line, which is the line A, is a porcelain filtering crucible, and the line B is the bottle containing is the weight of a bottle containing about 7.5 grams of KCl or potassium chloride. We can see that if both porcelain filtering and the bottle, which contains about 7.5 grams of KCl or potassium chloride, are removed in the drying oven for less than 20 minutes, it causes an absolute error. So in order to have a zero error, we need to dry both porcelain filtering and the bottle for 20 minutes before removing to the drying oven. So here is an example problem for us to solve. A bottle weighs 7.6500 grams empty and 9.9700 grams after an introduction of an organic liquid with a density of 0.92 grams per cubic meter. The balance was equipped with the stainless steel masses 8.0 grams per cubic meter. So we will correct the mass of the sample for the effects of buoyancy. Since the apparent mass of the liquid is 9.970 grams, we will subtract 7.6500 and we will have 2.3200 grams for the standard mass. The same buoyant force acts on the container during the weighing. Thus, we need to consider only the force that acts on the 2.3200 grams of liquid. By substituting 0.0012 grams per cubic meter for the standard mass, 0.92 grams per cubic meter for the density of the object, and for the density of the masses, we have 8.0 grams per cubic meter. Then we will follow the given equation, and our equation will be W1 is equal to W2 plus W2 multiplied to d air over the object subtract to d air over dWds. Or after substituting the values, we will have 2.3200 plus 2.3200 multiplied to 0.0012 over 0.92 minus 0.0012 over 8.0. And after some algebra, we will have now our corrected mass of the object, which is 2.3227 grams.